Mathematics. MATH0101. Mathematics. When we perceive our environment, we do so quantitatively and qualitatively. Example, we automatically measure and count, but we also look at color, beauty, etc. We then have to communicate what's in our minds, which are mental images and words that are based on the language that we speak. We communicate verbally, which is speech using songs, and symbolically, which is writing using diagrams, graphs, letters, and symbols. Hence, mathematics can be viewed as the language that we use to translate mental images and words to diagrams, graphs, single letters, and symbols to communicate in written form quantitative analysis. So it starts with the perception of the real, then we think quantitative and qualitatively, thinking using words, and then we write symbolically to communicate what we think. So essentially, every letter that you see represents something real to describe reality. The early Romans, the Roman numerals, the vertical line will represent 1, the x to the represent 10, 1, 2, x 12, 1, 2 is 12, but x and 2 strokes will be 12. But then you have the Indian Arabic numerals or present numerals that we use today, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is 1, 0 that we are familiar with. These Indian Arabic numeral symbols all developed by counting angles in a particular symbol. So you have the circular symbol does not have any angles, it represents 0. There's only one angle in this symbol, so we call it 1. This symbol has 2 angles, we call it 2. This one has 3 angles, we call it 3. 4 angles, 1, 2, 3, 4, we call it 4. 1, 2, 3, 4, 5, we call it 5. 1, 2, 3, 4, 5, 6, we call it 6. 1, 2, 3, 4, 5, 6, 7, we call it 7. 1, 2, 3, 4, 5, 6, 7, 8. We call it 8, and 1, 2, 3, 4, 5, 6, 7, 8, 9, we call it 9. So this is the symbolism that we use today for numerals, invented by the Indian and are promoted by the Arabic nations. The plus sign, the origin of the plus sign is credited to the 14th century French mathematician named Nicolas Deracem. When he was writing his math book, he found himself having to write the word et over and over. So in Latin, one would say, 3 et 4 acalia sont 7. 3 et 4 égale 7, that's French. 3 and 4 is equal to 7, English. So the word et is and. So he therefore then replaced the word et with the letter T, instead of writing et every time, which then evolved to the plus symbol that we know. So the words to speak, you will say et, which is and in Latin and French, and the symbol to write will be the plus sign that we know today. So take note, in arithmetic, the word and is plus, bear that in mind. So if you say 5.5, 5.5, you actually mean 5 plus a half. So 5.5 plus 4 is 5 plus a half plus 4. That's 9 plus a half. And 9 plus a half is 9.5. Okay? MATH0101 topics. We're going to do fractions and decimals, negatives, BEDMAS simplifying expressions. We're going to do linear equations, matrices, substitution, factorization, plotting of points. Now, for fractions and decimals, let's say you perceive the real, you perceive some books. So in your mind, you'll be thinking qualitative and quantitative thinking using words. Qualitatively, you would say there are green books, color. Quantitatively, you start to count. There are 2 green books out of a total of 9. So as a fraction, to write this symbolically, you could use X for green books and Y for books, because a letter represents something real. And X over Y would be 2 over 9, which is a fraction. And if you divide 2 by 9, you get 0.2 to recurring fractions to decimals, from the real to symbolically mathematical writing using symbols. Then negative numbers. Again, you can perceive the same image, and you may think qualitative and quantitative thinking using words. Qualitatively, you may say there are green books present. However, pink and brown books are missing. They have been taken away. Pink and brown books have been taken away. So quantitatively, writing this using symbols, you can use X for pink because you define what X to be here, Y for brown. So negative X interpreted means X has been taken away, all right? Negative Y means brown books has been taken away, okay? So negative X, missing X, brown books, pink books, plus and negative Y, missing brown books, okay? So negative numbers. That's the next topic we're going to be talking about. Then simplifying expressions, we're going to talk about that. Imagine you have this image in front of you. Qualitative and quantitative thinking using words is going through your mind. Qualitatively, you may say there are green, red, yellow, violet, and brown books. Quantitatively, we'll start to count. There is a means one. There is a green, a blue, a red, a yellow, another red, another blue, a violet, an orange, and another green. So to write this symbolically, all these words, green, G for green, B for blue, R for red, because you normally use the first letter of the word to translate the words to symbols. And a green is one green plus a blue, because plus is and a red, and a Y, and so forth. So you have an expression. This expression can be simplified because you have a green and you have another green there. So you can bring the groups together, the group up the greens, group up the blues, group up the reds. So expression is simplifying. Two greens, because 1 plus 1 is 2, 2 blues, 2 R's, plus 1 Y, plus 1 V, plus 1 orange. Each letter represents something real, from the real to symbols. Linear equations, again, you perceive the real, this image. Qualitative and quantitative thinking using words. There are books in one group and books in another group. Quantitatively using words, there is one group of green books and one group of 6 books. So you are counting. So quantitatively, you write B for book and you write 3 books plus 6 books is equal to 9 books. So here you have something real and here you have an equation to communicate the same thing that you are thinking. So in that regard, math can be a language. It's just a different way to communicate what you are basically describing, yes? Matrices, you have perceived something real. Qualitative and quantitative thinking using words. Qualitatively, we say there are green and violet books. Quantitative, 5 green books and 4 violet books cost $42. Also, 3 green books and 7 violet books cost $39. So these are words, quantitative thinking using words. Quantitative writing using symbols. So you use X for green, Y for violet. You define what X to be because every letter represents something real, depending on what you define it to be. So 5 green books and 4 violet books. Here it is, 5X plus 4Y costs $42. So that very same sentence, here it is in symbolic form. Maths is a language, translating from words to symbols. Again, 3 green, 3X plus 7Y is equal to $39. So you have a system of equations, and this system of equations can be rewritten in another form using matrices. Matrix is a set of numbers in rows and columns in a bracket. So 5 and 4, 3 and 7, as you can see, X and Y in another column matrix equal 42 and 39. So that's what you perceive, that's what is going through your mind using words, and that's what you write symbolically. So that's mathematics, communicating what you perceive using symbols. Substitution is another topic. Again, the same image, but you have different analysis. There are green books and violet books, yes? And the cost of a green book, cost of a green and violet book is $6 and $3 respectively. What's the cost of 5 green books and 4 violet books? So quantitative writing using symbols, G for green, V for violet, cost is equal to 6G plus 3V, because the cost of a green is 6 and the cost of a violet is 3. But you have 5 green, so 6 5s are 30. You have 4 violet, 3 4s are 12. 30 plus 12 is equal to 42. So here you have this in words, and here you have this symbolically. Each letter represents something real, using mathematics, using symbols to communicate what you perceive. Then you have factorization. That's another topic we're going to talk about. Again, the same image. You have qualitative and quantitative thinking using words when you perceive this. Qualitatively, you may say there are green and violet books, color. Quantitatively, you start to count. There are 2 green books and 2 blue books. So these words that you said quantitatively, you can write it using symbols. X for green, Y for violet, 2 green and 2 violet, 2 blue, sorry, because blue we talked about. 2 green and 2 blue. So since the 2 are repeated, you can factor it out. In brackets, you put X plus Y because you divide by 2. Factorization, the real to words to symbols, mathematics. And then you have graphs. We're going to talk about graphs. And anytime you see a graph, the line or curve that joins the points in any graph shows you the behavior of the Y variable. X is always increasing from left to right. So the X axis is always increasing from left to right. But then the line that you see will shows you what happened to the Y variable. Always bear that in mind. Here we define X to be time in days and Y to be revenue in thousands of dollars. So this line is showing you that as the days are increasing, your revenue is going up. This line shows that your revenue is increasing. And these points were plotted using this table of ordered pairs, -10 to -20, okay? -5 to -10, okay? And so forth. Let me just do a brief demonstration to show you how this can be done, all right? And here you have your points. If you want to point -10, -20, you want to plot a point, you first look for the X, yes, which is -10 in that case. And then you look for the Y, -20, -10 days, that means 10 days in the past from 0,0, for example, and -20, that means you lose $20. So you can define the negative here and days in terms of before the 0 days when you started to count. That's where you probably have your zero, the first when you started to count when you had made 0 revenue, and then negative means that you lost, okay? Let us plot this 0,0. So you first look for the X. The X in this case would be 0. We're going to plot this point there, 0,0. And that's the origin, and the Y is 0, so you stay right there. Okay, let's just plot one more point. In 30, in day 30, you made $60,000. Okay, so first you have to look for 30, you have to look for the X. Okay, you look for the X, and then you look for the Y. Okay, so let's look for the X, which is 30. There it is, time in days, 30 days. And then we have to go up now to look for 60. Okay, up we look for 60. Here it is, 60. And then you join with a line that shows you how the points are behaving. All right, so you join with a line, and the line shows you the behavior of the Y-axis, okay, which in that case is revenue. You can put it in bold so that it can be more visible, okay? And here you have it, increase the thickness. So this line shows you the behavior of the revenue as time increases.